purpose of this video is to go over number 9 and number 22 on 4.5. And these are some of my favorite types of problems because they're the application problems. They actually give meaning to a lot of stuff that we're doing. So we're wanting to find the maximum area that can be inscribed in a circle of radius 3. So if I come in here and I draw a rectangle that's inscribed into a circle, and I have a radius of 3. So seeing what I have here, the radius is 3, so the diameter is going to be 6, and if I call this x and I call this y, I need to write two equations that relate x and y together, so then ultimately I want to maximize x times y, the area equation. That's what I want to maximize. All right, so I need to write x in terms of y, and to do that, I can actually say x squared plus y squared is 6 squared. Sorry. So if I solve for x, I have x equals the square root of 36 minus y squared. I can plug this into my area equation and get the area is x times the square root of 36. Oh, sorry. It's going to be in terms of y. So the square root of 36 minus y squared times y. It doesn't really matter if you do x or y. Now this equation is kind of ugly to differentiate. So instead of dealing with this area equation, I'm going to square both sides. So the area squared is 36 minus y squared times y squared. So the area squared is going to be 36y squared minus y to the 4th. I'd like to maximize the area function, but I can also maximize the area squared. And then the maximum of area squared is going to be the maximum of just area. So maybe I'll call that, instead of area squared, I'm just going to call that P, where P is a squared. So now I'm going to maximize this P function. So I'm going to take the derivative with respect to y. I get dp dy equals 36 times 2, which is 72y, minus 4y cubed. And I want to set that equal to 0. So I factor a y, you get 72 minus 4y squared equals 0. So y equals 0, which is not going to be a maximum. Or I have 72 equals 4y squared, which solving for that, dividing both sides by 4, I would get 18 equals y squared. Take the square root of that. Will get plus or minus, but of course, square root of 18. Then if I plug that back into this function, I can solve for x. X is the square root of 36 minus 18. So I take 36 minus 18. 36 minus 18. That would give me 18. So this answer is the square root of 18 as well. So that's that question there. So this would be the square root of 18, the square root of 18. On this question, we have to come up with a function for volume and a function for the cost that it takes to make this square box, this rectangular container with a square base, right? So if I come in here, I have a square base. It doesn't look very square. I have a square base in a rectangular container. So this is SSH with some height on it. So the volume is S squared times H. So there's our volume function, and that's going to equal 2592. Surface area, well, this is a closed container. so it's closed, so it has a top and bottom. The surface area of the top and bottom would be S squared plus 4SH. Now we have to talk about the cost. The cost is $3 for the top. So the surface area cost is going to be 3 times S squared plus 2 for the sides. So this is 3S squared plus 8SH. This is the cost function. This is what we want to minimize. So if I take the derivative with respect to S, it's going to minimize it and tell me the S value. Now to do this, I need to get H as a function of S, and that's where the volume function comes in. So if I solve for H, I end up with 2,592 divided by S squared. I plug that in for this H, and I end up with a function of only S. 3S squared plus 8S times 2,592 divided by S squared. So cleaning this cost function up a little bit, I end up with 3S squared plus 20,736 over S. Now I take the derivative with respect to S. So I have the derivative of the cost function with respect to S. It's going to give me 6S minus 20,736 over S squared. Now I set this equal to 0, and I get multiply both sides by S squared. I get 6S squared equals 20,736. Here, no, S cannot equal 0. That's fine. So S squared is 20,736 divided by 6, which would give me, oh, sorry, that's not S squared, that's S cubed. If I multiply both sides by S squared to cancel that, I get S cubed. So if I take S cubed is, if I take the cube root of that, I get 12. That's what gives me S. S is 12. If I plug S back into my H function, H 2592 over 12 squared, that gives me 18. So my length of the edge of the base would be 12, and the height would be 18 inches. And that's going to give me the minimum cost to create this container that has this given volume. So hopefully this video is helpful. If you have any questions, please let me know.